Hello everyone. We are going to see that production of pure spectrum and its condition. So see carefully the phenomena of pure spectrum. In this pure spectrum, see first of all, when white light falls on prism, we know that when white light falls on the prism, what happened to this white light? Separated into its constituent colors, all 7 colors. This phenomenon is called dispersion of light. We know, well know. And due to this phenomena, color band obtained is called spectrum. So let us see how this spectrum is obtained by this diagram. In this diagram, let's see a prism. A, B, C. Let a white source of light, S is here. Although here is a narrow slit, but in place of being a single ray of light, a group of ray of light is emits from it. It is shown from here to here. The end's color of light, white light, is represented here in the diagram. On the prism, let us see the normal at both places. We are knowing that this white light is divided into its constituent color. Let us see the first ray. This division is from violet to red, and it happens from here to all ray of light here. Let's see in the last end color. It was first, second, from violet to red. Again from prism to medium air, again phenomena of refraction takes place, and let violet ray, this violet ray reflecting here, let this is screen, white screen is here. This white violet one, this is red one, violet 2, red 2. See here in it, when we see this pattern from the second, you see in the diagram. And when we see with the first end color here, here. See, this is the overlapping pattern. In that condition, the spectrum pattern get overlapped, mixes with each other. We can write here violet 1, red 1, violet 2, red 2. Here in the diagram, see carefully, it's shown for end color only, but when we see for all 7 constituent color, it's become much mix up. This much mix up color pattern is called impure spectrum. Impure. In the impure spectrum, we can see that color patterns are overlapped, not clearly visible. Then here is a question arises, how can we see the pure spectrum? So see the concept of the pure spectrum first of all, that the pure spectrum is that when all this color means 7 color from violet to red in spectrum, if it is seen clearly separated, that is no overlapping, then this spectrum pattern is no overlapping, clearly separated, then called pure spectrum. This pure spectrum has some conditions to obtain. It is not generally obtained. Generally, this unclear spectrum pattern in when one color is mixing by another and it is not clearly distinguishable. So for pure spectrum, there are certain conditions. In that, first condition is, see very carefully, the source. This slit here, to make a white light in pencil beam. This is a white light in pencil beam. This slit must be as narrow as possible. This is the first condition. The slit must be as small as possible. It should be narrow. Second condition is also very important, that is the white light falls on prism should be parallel. This is the second condition. Now see one third condition. Its since second condition should be parallel. See, the incident ray falling on the prism is not parallel here. It should be parallel. Third point, the emergent ray should be focused on screen by something, by any way, that is called, we are doing in the pure spectrum by achromatic lenses. Achromatic combination of convex lens. This is the third condition. We know that achromatic in condition, then color aberrations are removed by achromatic combination of lens. And finally, see the last condition. In the last condition, the position of prism should be placed in minimum angle of deviation position. This all four, if you are applying the condition as possible as in proportionate, then in place of getting impure spectrum, pure spectrum can be obtained. So let us see in the diagram how, by applying all these four conditions, pure spectrum can be obtained. See the phenomena of pure spectrum by the prism. Let us see the position of prism. This is the prism, and let us see, this is white screen. See carefully the ray diagram. If you are able to understand the concept of the ray diagram, then it will be clear completely the fundamentals of it. Now see here, in it a source of white light should a narrow slit as small as possible. We are taking a narrow slit as small as possible, but see very carefully. But by this condition only, we cannot take a single beam of light. It will be multi-directional. It is possibilities are there. See here. Now we are using achromatic combination of convex lens. See here in the diagram. In achromatic combination, we know that there are two lenses, combination of convex lens and concave lens, in such a way that its resultant is a convex. So it is known as achromatic combination of convex lens. So achromatic lenses are combination of two lenses, one convex and one concave, but its resultant is a convex. Let this is L1 lens. The distance between both is kept equal to the focal length of it. We know that in that condition, if source is at a focal point, then after refraction through the lens here, in this ray becomes parallel to each other. Here in it. So it's completing two conditions we have completed. What is the first one? Slit must be as narrow as possible and white light falls on the prism should be parallel. The two conditions are fulfilled here. Parallel, this is the white light becomes parallel. Now see, when it's fall and position of it's kept the third in such a way that here when it's fall the angle of incidence is kept in such a way that the angle of deviation should be minimum in here. So see, the in that condition the ends color violet, red, violet, red. This time first we are showing in above and second is in it. Now see, we are using one more achromatic combination of lens. Same way, let the first achromatic combination is represented by L1, so it is by L2. What does it do? When it's the achromatic combination, when see here this violet, violet and red, violet of ends color, see violet of end color, these two, see after refraction when it's fall on the lens L2, see the violet of first here and the second. When they fall here in such a way, both becomes parallel. As a result, the distance between both L2 lens and here also kept equal to the focal length of it. Let its focal length is f1 and it's f2. In that condition, all these violet rays meets at one point. Same situation arises when the red color of the end fall here, second and this first. This also for the red color. When this fall on achromatic combination of lens, it becomes parallel, and then finally after refraction, they meets at a focal point. So all red color combine at one place, violet color in one place, and all constituent color in spectrum pattern have their positions at one place: indigo, blue, green, yellow and orange. As a result, clear spectrum pattern is obtained. Clear spectrum pattern is obtained. This means that no overlapping. This is called pure spectrum. in that condition, all four conditions of the pure spectrum is uh, applied here, and a device in which these all conditions are applied is known as, see carefully here, is called spectrometer. This is for the topic. Thank you and have a nice day to all.